Hi, yeah, thank you very much. So I just pasted in the chat a link to the presentation. And this is not a PDF, it's a Reveal.js presentation. So that's a presentation that is a build for the web. So it's not, you could download it, but I think it's a lot nicer to watch it in the browser. And you can trust that this link is not going to disappear. So you can bookmark it if you want, but you can trust that it will stay there. And yeah, let's get started. So this is really a demo, a very brief demo of what R is capable of. Okay, so let's start with a few words on what R is. So it was started by two statisticians teaching within a university, Ross Yaka and Robert Gentleman. The last one is actually Canadian. And it builds on a language that existed before that is called S, hence the name, and also R conveniently was the first letter of Ross and Robert. So that's why they called it by this name. And initially it was really a tool that they built to teach their students statistics. But then it really grew and became increasingly useful. So they launched it officially in 1993. And then in 1997, it got incorporated into the GNU project, which is a big, great open source project that involves Stallman and contains amazing tools such as Emacs, etc. And so R is fully part of the GNU project. And there are many good reasons to consider this language, amongst other things. And Megan mentioned that I am an open source advocate, and that is very true. R is free and open source. And Alex mentioned the benefit of free and open source tools when he talked about Python. So everything he said about Python absolutely applies to R. It's actually very similar in many respects to what Alex said about Python. It's also very high level, so it's really easy to learn. It's also extremely well documented. It has a large community. It has an absolutely astounding number of packages when it comes to statistics and modeling, because again, it wasn't created by software developers the way languages usually are developed. It was created by those academics who were statisticians and who built a tool to serve their needs. So it's really, at its heart, a statistics language. It has an integrated package manager, which is super convenient. You don't have to deal with like 20 different methods on how to install packages, as is the case with Python. And it has a fairly easy way to connect with compiled languages that are going to be incredibly faster, such as C and C++. And on top of all of that, one of the things that might have given R an added popularity in the past 10 years or so is that really great IDEs, so that's environments that make using a language a lot nicer and a lot convenient, have been developed for R. So Alex introduced you, and before Alex, there was a whole presentation on Jupyter. So Jupyter actually stands for Julia, Python, and R. That's why Jupyter is spelled with a Y. And so R is part of the Jupyter project. So there is an R kernel that runs in Jupyter Notebooks and Jupyter Lab. So you can run R through those interfaces. But in addition, RStudio is a really popular IDE that was built and that makes running R very friendly. And there are additional ways. And because I like an additional way that uses Emacs, this is what I will show in this demo. Now, who should be interested in learning R? R might not be relevant for everyone. As I'll show in the next slide, there are some downsides to R. And some people in some fields just have never heard of R or think it's a big joke. So not everyone should worry about R, but if you are in data science or in one of the academic fields that rely heavily on statistics, particularly economics, linguistics, a lot of the social sciences, biology, then because of all of those very technical, very pointed packages for Bayesian inference and modeling and statistics, R is a fantastic tool, and it has become the norm, like the absolute norm in some fields, such as, for instance, biology. People in biology all use R if they want to publish. So it is very important in some fields. However, it has some downsides. Because it was developed by those academics, those statisticians, and not software developers, it's very weird, it's full of quirks, it has an inconsistent syntax, and people who come from standard programming languages usually pull their hair off when they encounter R. It's also incredibly slow, even slower than Python. Alex mentioned how slow Python is. Well, R is way, way worse. And it also uses a lot of memory. So it's fantastic if you're in some fields, but in other places, it's just not the right tool. So it depends what you're wanting to do. Now, how do you run R? There are many options. It is an interpreted language, as is Python. So that means that there is an interpreter that allows to run the code interactively. That said, it can be run non-interactively. You can write all of your code in a text file. So then that's called a script. And instead of using R, there is a command that's called rscript that allows you to run your script on the command line. And why would you want to run an interpreted language non-interactively? Well, there are many situations where that's extremely convenient when you want to automate things or when you want to run your code more efficiently on the Alliance clusters, etc., etc. So one of the advantages of R is that it is an interpreted language. That's what makes it slow, but that's also what makes it really easy to use because you have an instant feedback from the language about your code. And there are many ways to run it interactively, as I mentioned. So the very simple, basic way is to just launch the R console. This is just the console. This is just R without all the IDE, without all the fancy stuff around. There's no syntax highlighting. There's no blink, but R is running like that. Now, it's not very friendly, and people tend to use either Jupyter notebooks or, as I mentioned, RStudio. Now, what I will show you throughout this workshop is what I do use to run R. Don't let this perturb you. This is Emacs. It's a text editor that also belongs to the GNU project. And so on the right side of my screen, I have two different panes. And on the left side, that's my script. That's the code that I will run for some of the examples. And it's exactly the same code as the one you have on the slides. I just copied and pasted it to save time. That's it. And on the right side here, this is the R console. So that's the R language. You can see that it looks just like this, except that now we're at version 4.3.2. And when I took this picture, it was 4.2.2. But this is the R console that is running in Emacs as well. And there is a little shortcut that allows to send commands from the script to the console, very much in the way that it works in RStudio for those who are familiar with that. So don't let the way it looks perturb you. There are just very many ways to run R. Now, a few basics. Documentation is fantastic in R. It's really, really extensive, very homogeneous, very well developed. And if you put a question mark before a function or before any element, here, for instance, the sum function. So I'm going to press my little key binding, and up, that sends question mark sum automatically into the R console here. And so that opens the R documentation for the package base. So that's the most basic package that comes bundled with R, and that gets loaded automatically in every session. And so sum does the sum of vector elements. That's a little description. That's an example of usage with an explanation of all the arguments, and then a bunch of details, details on what you get when you run it, and then a number of examples. And the examples are always things that you can copy paste and run directly. So they don't rely on additional packages or additional libraries, additional data. You can just copy anything, paste it in the console and run it. And that is extremely convenient because sometimes the explanation of what something does, what something is a bit obscure, but running the examples can really help. Well, in this case, sum was pretty straightforward, so it was quite self-explanatory, but sometimes those examples are fantastic. So just remember to try them on. And the reason I'm spending a bit of time on this help page is that every single help page in R, including R packages that have been added to the official R repository that is called CRAN, all have exactly the same documentation following exactly the same structure. It's extremely homogeneous. So once you know how to work and understand the help file for one thing, you know it for everything. So of course, in R, you can do basic operations. So you can sum, and you can assign some values to some names that then become variables. So for instance, now I can call A that has the value 4, and I can use it for operations. But I want to move very fast to the kind of things that R can do. So this is why, because R really shines with statistics, probabilities, and modeling, we will spend the rest of the hour into very complex, heavy, dreadful, and really hard to understand Bayesian statistics. No, I'm kidding. We will just do some fun things for today, some cool topics and some light things, just to show you that R can be cool. It does do the heavy-duty statistics, though, and we will cover some of it in 2 weeks. But for today, let's look at a couple of fun things. First, data visualization. So here, you can follow along in the slides, but I have pasted all of the code, and I will run it so that you can see R behaving interactively. So R comes with a number of data sets. So as soon as you install R, in addition to a number of functions and etc., you actually have access to some data set. And if you want to see the list, you can run the function data, and that will output the whole list of all of the data sets that come bundled with R, with some explanations as to the type of data, whether they involve factors, etc., and information on all of them. Now, when you install additional packages, some of them come with additional data. And that's the case of the package ggplot2, which is the most popular package in R for plotting. And so to load a package once you have installed it, and I have already installed it on my machine, you use the function library. So library ggplot2 loads this package and gives me access to everything that is in that package. So now I have access, for instance, to a data set that's called MPG for mile per gallon that belongs to ggplot. And we will use this data set for plotting. So ggplot, it's called ggplot because it uses a grammar of graphic, and it builds things in a kind of layered fashion. So first, you have to add the data, and then you have to tell R what the axes are, and then you have to represent the data in some fashion, and this is done with what is called a geom, or a geometrical object. Here, geom point. So let's run this. Yeah, put it below. So if I just pass the data, which is, so the data set MPG, as a value for data in ggplot, I just get the canvas, really. So it's not super interesting, but then I can add the axis and a representation of the data, and I can change the color of the dot based on the class to which they belong, and I can run this for various classes. I'm not going to go into the details of what this data is, what it represents due to lack of time, but it's a convenient way to visualize various relationships within the data. And you can also add what's called a geom smooth, so an additional representation of the data. Here I have two geoms. The first one, so that's the raw data, the little scatter plot. And then I'm adding to this a smoothing function that approximates the data. And by default, it's a lowest function, so it's a locally estimated scatter plot smoothing, but I can replace it with a linear model method instead, and then I get the same scatter plot and a model that aims to represent the data, but this time it's a linear model instead of being a lowest model. And the little gray area that you see around, or I guess it's pale blue, those are the standard error of this model. So I can run it for every single class, although that's a very busy plot. I can also remove the standard error and change the format of this geom smooth. So here I've removed the standard error and I have changed it for something a little bit more subtle. I can also change the color scales. So for instance, I'm going to use the dark 2 color themes, and there are some color themes that are specifically for people who have various color vision impediments. So this is based on color brewer. So here I have changed the color theme to the theme dark 2. But my plot still needs a lot of information, so I can add some title and labels, even the little caption at the bottom that you probably cannot see. I can change the theme using theme classic. It's going to remove all of the background, all those lines. Those lines can be very useful to estimate where the points fall, but maybe you want something that looks cleaner, and so you can change the theme, and you have all of this in your slides with some explanation. And I see that time is flying, so maybe let's not run all of it, but you get the idea. And ggplot comes with very many extensions. So there's 132 packages that are registered inside CRAN, so that is the official R repository, and there are many more that are unofficial. So this is the CRAN official repository that contains all of the official packages that are all contributed by the community. It's all open source, it's all out there, available for free. And it also contains the archives of all of the R versions. So there's 132 extensions that build on top of ggplot and allow to do things such as animating your plots or create all sorts of fancy plots of all kinds using ggplot as a GS package, etc., etc. And for instance, one package that is extremely popular, that's why it comes first, is Patchwork. And what it does is that it allows to combine various plots. So here I'm loading this other package, and I'm reusing my first plot, but I'm also adding a second plot and tweaking the labels and things a little bit, and now I have another plot next to it. So very superficial, but it's a little demo of how to do very simple two-dimensional plots with R. Now, Alex gave an example of web scraping with Python, and I'm going to show exactly the same thing with R. So you've seen this with Alex, but HTML and CSS come with a number of markup, and this markup can be used to extract data from websites automatically with Python or R or other means. And R has a great package called Harvest that allows to do that in a very convenient way. And for instance, in HTML, you have some tag that set the class or the category of some element, and the content, what the words that you see on the screen are, is in the middle. And so those tags will set, for instance, that something is a header or a heading of the second level. And then the CSS file will determine the formatting of heading of level 2. So your content will behave as a heading of level 2 if you have H2 as the tag, and will be formatted with the formatting of a heading of level 2. And then you have formatting for bold, italic, etc. Websites are just written in this fashion. And so you can take advantage of all those tags and attributes to automatically extract bits of the sites that you're interested in. Because when you want to scrape a website, you're not interested in just downloading the HTML data. The HTML is just full of all of this formatting that, of course, you're not interested in, and all sorts of information that's totally irrelevant to you. You just want to automatically fish snippets of data in the websites and then put it in some nice format that you can reuse to do some analysis, some plotting, or whatever later on. And the example that I'm using is exactly the same one that Alex used. So it's a website at the University of Tennessee that contains a database of PhD theses. So this is the website, and for each thesis, there is a link. And if I click on that link, that takes me to a page just for that particular thesis. And then there's a bunch of information. And let's say I'm interested in extracting for all of those links of that first page. So there's 100 of them. For each of these links, the link that leads me to the page of the specific thesis, because then from there, I want to extract the date of that thesis, the major, so the field, and who the PI was. So of course I could visit the website, spend a couple of days copying and pasting, but that's not the approach to do this. Web scraping allows to automate all of this. So Harvest is the package that allows to do this. As I said, we can assign a string with the URL of the site to an object, like a variable that I'm creating. And then I can use that function read HTML from Harvest to create an HTML object. And that HTML object contains all of the HTML markup that is behind the website. And from there, I can extract all of the URLs for all of the theses by selecting for the proper classes that correspond to the URLs I'm interested in. And then I can put all of those into a list. And finally, write a loop exactly as Alex showed in Python. So this shows that most things can be done in either R or Python. And there are advantages or disadvantages of either language, but usually people go for one or the other based on the field they're in, the culture of their field, what the literature uses, what packages are there that are useful for their field, but the packages can do the same thing in fairly similar ways. So I have here a for loop that will allow to extract the attribute href, thanks to another function here from the harvest package, of each element of my list. And to make sure things are working, I can index this square bracket is indexing, and I have two of them because I'm indexing an element of a list. This is one of the little quirks of R, that to index out of a list, you need nested square brackets. I can extract the URL. And now that I have a list of all of those URLs, I can do for each of those URL the extraction of the elements I'm interested in, which are the publication date, the department, and the advisor. So I have another for loop here. This little symbol here is a pipe from the tidyverse. It's a Margaret R pipe, which allows to chain functions so that you have A that goes through a function and turns into B, that then the result B becomes the input of the following function, and then the output C can then in turn be chained to another function. And this is something that is a bit easier to read for a human than the alternative syntax, which is to nest function within function, where you have A that gets into a function that becomes B, and all this is nested into a bigger function. So it's an alternative syntax. And then once I have this, I can create a data frame with some headings that I'm creating that I call date, major, and advisor. And I end up with an object. I'm creating this object here and adding some headers to it here that I call that object result. And here I am showing the first 15 elements of that object. And you can see that I have, for the first 15 theses, the advisor, the field, and the date in a nice little data frame. So exactly as you saw with Python. And I could, of course, write all these to a little CSV file. So I'm skimming through the code very quickly because I'm not here trying to teach you about web scraping with R. I have a workshop on that. So if you're interested, I could pass the link so that you can go over the workshop step by step in more detail. But this is just to show you the kind of things that R can do. Another little example is GIS mapping and geospatial data analysis. R is fairly popular for that. When you want to do things that involve a lot of visualization, pinpointing of things, things like QGIS might be more convenient. But when it comes to doing analysis from GIS data, R is very popular because it's really, it has a lot of packages, and it's, again, it's very great as soon as you're doing any statistics. So here, if you want to see the full code, you can check a webinar and a workshop I gave with that. But here I'm just going to give the final results of little maps, that very, very basic little maps that you can do with R. Things can be way more complex, of course. For spatial vectors, you can use SF or Terra. Both are two modern great packages, replacing respectively SP and raster. And for raster data, meaning for areas, you can use the package Terra. So Terra does vector and raster, SF just vector. So a vector is anything that's going to be like a point, a line, a boundary, a perimeter. A raster is going to be an image, a satellite picture, for instance, things that involve a pixelized or a more filled-in, tabulated representation of the data. So there is some open source data on glaciers in Western North America, and once you process the data with the packages SF or Terra, then you can use another package called tmap to just map this data. So these are a bunch of functions within tmap to which I'm passing a bunch of arguments, And what that can create is a map of the glaciers of Western North America based on some data online. So again, while R is usually not used so much for creating maps, more for the underlying GIS analysis, you can totally create GIS maps with R if you want. Another example is the retreat of a glacier called the Agassiz Glacier. Again, there is data available. There's data for the perimeter of the ice over a series of, I can't remember, 5 or 6 years. And again, with TMAP, with not too much code, you can end up with a map with the various layers. So yeah, there's data for 4 various years. So in 1966, the Agassiz Glacier had this extent, and then you can see it shrink for each year when data was collected. You can also create an animated map of the exact same thing, and then you can see the animation of the shrinking of the glacier. So how to get started with R, because here I'm just throwing a couple of things at you, and I might have piqued your curiosity. If you are in the right fields, again, R has its downsides. So if you are in a field where none of your colleagues use R, there's no mention of R in the literature, probably you should learn some other language. R has its downsides. Mostly it is very, very slow. But for instance, if you want to do a lot of machine learning, R is not ideal. And if you want to do some deep learning, forget about R entirely. But if you are in a field where a lot of people use R, then it's really worth considering it, because despite its little quirks and its slowness, because it has this insane community of academics behind it, it is extremely likely that you will find a package already written by someone to do this very weird statistical analysis for this very quirky edge case that's going to match what you want to do. Because there are so many of those packages for those very weird edge cases of statistical research. And a language like Python could totally do the same things, but because it doesn't have such a huge stats community behind it, it's much less likely to have a package that will provide the right Bayesian approach for your fancy modeling or analysis. Another language you might want to consider if you're into fancy statistics is Julia. Julia is a newer package, but it is much faster than both R and Python. And it is also extremely statistically oriented. And it has a growing number of packages that will do the kind of things that R packages do. So if R is too slow for you, but you want something that's really statistically oriented, maybe Julia is something you want to consider. If you're more interested in deep learning, then maybe Python might be more the direction where you want to go, because even though Python is slow, not as slow as R, but pretty darn slow too, there are a number of packages that have been built for Python, written in C or C++. So you write Python, but it's written in a compiled language under the hood that allow you to do a lot of deep learning very efficiently. But if you think that R might be the tool for you based on your needs, your fields, the literature, etc., then how to get started. So beyond that, since R is free and open source, and it has this huge community behind it, there's a lot of workshops out there. There are some excellent books, for instance, R for data science. So that is a book that is focusing exclusively on using a set of packages called the tidyverse, because the author of the book is one of the main developers of the tidyverse set of packages. So it has a very opinionated philosophy about R, but that is the modern philosophy that is taking over, and it is extremely well explained, very friendly, and is a very gentle introduction to using R with the tidyverse. And I didn't click on all the links, but all of the things that I have mentioned throughout are linked, so you can follow these links. Another thing that maybe I will post in the chat is CRAN. You don't really have to visit this page because it's just an archive. You don't normally, it's not a website that you browse, but it is the official archive of R. So I'm just pasting it here. So there is a lot of ways to learn R on your own out there, but also all of the regions within that are under the Alliance umbrella. So AceNet, SharkNet, Compute Ontario, Calcul Quebec, etc. They all offer regular free courses and workshops for people who are studying or doing research in Canadian universities. And courses and workshops on R do come up fairly often. In the West, Alex, who is in the audience, and myself, we do offer some workshops and courses on many topics, including R. And so if you are interested in hearing from us, you can join our mailing list. I pasted a little link here, or follow our program. I pasted a little link there.